When we find the first derivative of a function is equal to 0 at some point, that's an interesting thing for us because it might mean that it's a local maximum or a local minimum value of a function. So far, we've been using what's called the first derivative test to check to see if it's one or the other or neither. So the first derivative test says we look at what's going to the left and right. And so if a first derivative goes from positive to 0 to negative, let's think about it. Positive derivative means it's increasing, and then it stops at 0, and then it starts decreasing. So we have a local maximum there. On the same spot, if we are going from negative to 0 to positive, then it's decreasing, stops, and then starts increasing. So that's going to be a local minimum. That's the first derivative test. We can also use what's called the second derivative test. So let's take a look at that right now. So the second derivative test says, we start off the same way we do before. So if f prime of x is equal to 0 for some x, it could represent a local maximum or a local minimum. And not surprisingly, we're going to use the second derivative to use the second derivative test. So if the second derivative of a function at x is greater than 0, f is, it's positive, so it's concave up. Let's take a look at what that means. Concave up function looks like that. So f is going to have a local minimum at x. On the other hand, if the second derivative of x is less than 0, then f is concave down. So it looks something like that. And now it's clear that our turning point is a local maximum. And if the second derivative of x is equal to 0, then neither is the case. F is not a local extremum.